Hello ladies, in this video we're going to go through solving quadratic equations using the quadratic formula. Now, as I've said in other videos, you can use the quadratic formula for any quadratic equation, which is pretty easy to use and will probably become the formula that you use mostly to solve quadratic equations because, first of all, when we're solving quadratic equations, we're effectively getting our x-intercepts. Okay, so we want to find out where our x-intercepts, where our parabola crosses the x-axis, or where our x-intercepts are. But we also need to know those other forms, especially completing the square, because that puts it in turning point form. So I kind of explained that a bit in the previous video, and I won't go through that now. But using the quadratic formula you can use for any quadratic equation, but just remember that not every quadratic equation will have a solution. And as I explained in a previous video, your parabola can move around. So I might just quickly show you now my calculator, which I wasn't preparing to use, but I might just put it up anyway. So let's just start. Oops, no, we want to do a graph, sorry. Okay, so let's just do your basic parabola, which is x squared. And there it is in blue. Now, your quadratic equation, or your graph, your quadratic graph, which we call a parabola, can move around. So if your quadratic moves up, and I'm going to just draw another one that moves up. Just bear with me while I do that. So you'll notice I put +2. That when you come to do parabolas and learning about the transformations of parabolas, you'll effectively know that. That means we're shifting the graph up 2. So there it is. And now the blue graph has sat on our x-axis. So that means it has an x-intercept of 0. This red one doesn't sit and it doesn't cross our x-axis. So it doesn't actually have any solutions. Whereas if we moved it down, so let's do one that moves down. So I can do x squared minus 4. So it means it's now shifted down 4. See how it's crossed our x-axis? And if we solved x squared minus 4, you would see you'd get your two solutions. And that's where they cross the x-axis. And it's actually at -2 and 2. But we don't really need to do that just now. So when I talk about the number of solutions, you can have one solution, which is the blue one, where it sits on your graph. And it's not always at 0, okay? It can move left or right. So I'll just show you, just thinking on the top. Actually, I won't show you just yet, because sometimes I like to be prepared. I don't want to show you one that hasn't moved. But the blue one intercept, okay, it's sitting on the line. The red one, there's no intercepts, okay? So it's sitting above. It's not actually crossing your x-axis. And then the black one has 2 intercepts. So we actually have 3 types of solutions. We can have no solutions, which is the red one, where it doesn't cross. We can have one solution, where it just sits on the x-axis. And we can have 2 solutions, which is your black graph. Okay, so when I talk about that, that's what I'm talking about, those graphs actually moving around. And that is what the second point is. So maybe I'll cover that first before I actually cover the first point. Now we call, oops, sorry, my emails were on. I don't like my emails popping up during videos. So the discriminant is basically what we use to tell us whether we have any solutions. And you'll notice the discriminant, b squared minus 4ac, is just what goes under the square root sign. Okay, so do you see that? Now, your knowledge about taking the square root is we can take the square root of 0, okay, which is 0. You can take the square root of a positive number, okay, and if you took the square root of a positive number, you actually get 2 solutions. That's why we've got 2 here, okay, and I'll explain that more in a second. And if it was a negative number, you don't get any real solution. So I don't want to go into imaginary numbers at this point, but if you go on to doing specialist maths, you'll learn about imaginary numbers. So that's basically what the discriminant is, b squared minus 4ac. We use the triangle symbol to refer to the discriminant. So when the discriminant is less than 0, so that just means when it's negative, we have 0 solutions. When your discriminant is equal to 0, we have 1 solution or 1 real solution. And when your discriminant is greater than 0, when it is positive, we have 2 real solutions. Your quadratic formula, first of all, if we've got a quadratic in the form ax squared plus bx plus c, as long as you can identify a, b, and c, you can do the quadratic formula. This part here is just saying when a doesn't equal 0. So if a was 0, basically we would have a linear graph. Okay, so that x squared component would disappear because it would be x squared times 0. So you're just turning it into a linear graph, and that's what that means. All right, I'm not going to talk too much about this quadratic formula or how it came about. But basically, if you wanted to do completing the square, it's quite similar. All right, so let's scroll down. Now, I added question 2, even though, the earlier questions are a bit easier, just to show you how to use the discriminant. Try to get in the habit of always writing any formulas just so you can get used to them. Okay, so our discriminant is equal to b squared minus 4ac. It's been a while since I've used this, so I might just double check that I'm right. Okay, cool. So I'm just going to leave that there. So maybe when you do your work, even if you wrote it at the top of the page, so you can always refer back to it. All right, so question A. Now, first thing you should do is identify your A, B, and your C. So A is the coefficient of x squared, so in this one it's 1. B is your coefficient of x, so in this one it's 5. And C is your constant, which is 3. Now, if your equation is not in this form, you need to rearrange it to put it in this form. So when we do question 6, you'll notice that they're not in this expanded form, and we just have to rearrange the equation to get it in that form. All right, so let's do our substitution. So b squared. Now, sometimes b can be negative. So remember, when you square a negative number, you get a positive, but this time it's a positive. So 5 squared minus 4 times 1 times 3. So we've got 25 minus 4 times 1. So 4 times 3 is 12. So we get 13. So you got a positive discriminant. Okay, so your discriminant is equal to 13. So how many solutions do we have? So therefore, 2 solutions. All right, let's do one from the second row. So I'm just having a look. Now they're all pretty straightforward. I don't know which ones have no solutions or which ones don't. So let's do D. Okay, so in this case, A is 1, B is 7, and C is negative 3. All right, so B squared, so 7 squared, minus 4 times 1 times negative 3. When you've got negatives, I always like to put things in a bracket. All right, so let's just focus on this bracket first. Obviously, you can do the 7 squared, which is 49. 4 times 1 times negative 3 is negative 12. So 49, even if you can't do this, you know it's going to be positive, but hopefully you can add 2 numbers together. So that's going to be 49 plus 12. I say that and I'll probably get it wrong, so 61. So therefore, we have 2 solutions. All right, so they're not all going to be 2 solutions. So I might do F. I'm just looking at the moment. Actually, I don't know if any of them are going to turn out. Maybe B. I think B might give us a negative. Let's try B. Okay, scroll up and get my values. So 1, 3, and 4. Okay, so all I've done there is the coefficient of x squared, coefficient of x, and your constant. So your discriminant formula, so I'm just using that, b squared minus 4ac. So b squared, so 3 squared, minus 4 times 1 times 4, so a times c. 3 squared is 9. 4 times 4 is 16. So we're going to get negative 7. And because it's negative, we have no solutions. Okay. I think you've got the hang of it. Well, I don't know because I can't see you watching this video, but the discriminant is pretty straightforward. You can actually, oh, sorry, I'm just thinking if you can do it on your calculator. From memory you can, but it's so easy to do by hand. By the time you put everything into your calculator, it's probably just easier to do by hand. And you need to also know how to do everything like all this by hand as well. Okay, question 4, now we're going to actually use the quadratic formula. So I'm going to write the quadratic formula first. So I'm going to just scroll up, just make sure I write it in the same way. I'm going to be doing a bit of checking. So we have 2 solutions. Sometimes you see it written like this. And oh gosh, is it 2a? Sorry. Just want to make sure I'm writing it correctly. Okay, so you'll see the plus or minus, and eventually you'll probably write it this way, because when you think, if you're writing it down twice, and what I mean by that is we have 1 plus here, and then the other solution here. Okay, so that's how it was written in the, oops, don't forget the 2a. That's how it was written in your key ideas. This way just means you don't have to write this twice. Okay, and it's at the end that you'll do the plus or minus. So I might actually do it that way, because I think if you like, you can do it this way, but you're going to save time just using this because you're not writing it twice. Okay, so let's do question A. All right, so the first thing we need to do is identify your A, which is 1, your B is 4, and your C is 1. Okay, so we're identifying A, B, excuse me, B and C. Now I'm assuming we can find the solutions for all of these. So let's go ahead and do that. So I'm going to just write the formula again. If I can remember it. Okay, and then we just do a straight substitution. See how I've got the x equals? Okay, that's because that's your x-intercept. So negative 4, so b is 4, plus or minus b squared, so 4 squared, minus 4 times 1 times 1 over 2a, so 2 times 1. Now, eventually you'll be able to skip that, probably that step, and do most of that in your head, but let's just keep going. So 4 squared is 16. 4 times 1 is just 4. And then 2 times 1 is just 2. Okay, so negative 4 plus or minus 16 minus 12, so 12 over 2. And we need to simplify that third. Okay, so the square root of 12 becomes 2 root 3. Just double checking in my head. Over 2. And at this point we can separate them. Okay, so remember I said this plus or minus actually represents the 2 solutions. So at this point I will then do my separation. So I've got the plus, and then I've got the minus on this side. And then I can divide everything through by 2. So -4 over 2 becomes -2. Those two cancel out. And then on this side, we've got -2 minus √3. Okay, so there's your two solutions. All right, let's scroll up and do another one. So I'm going to do a non-monic now. And you see it's a lot of working out. So you don't have to do every single question. All right, let's do, oh, why did I write B? I don't want to do B, I want to do F. Let's just write that out. All right, so A is -3, B is 8, and C is -2. Oops, scroll down. Now I've got the formula there for A. Okay, so see how I've written it here. So I'm not going to write it again. Although you probably should, but you don't want this video to go on forever. So, all right, so 8 squared you can do. So remember I said you can do things as you go. You don't have to write them. But now I might do the 4. I might expand that just because, oh, I'm running out of room. Oh, let me just go back and do that. Get a bit more space. Okay, so B squared, so 64, minus 4 times -3 times -2. All right, remember I'm going to put that around brackets just so I don't make any mistakes, or I'll limit the chance of making a mistake. Then down the bottom is 2a, so 2 times -3 becomes -6. Okay. All right, so I'm going to just ignore the negatives for now. I'll do 4 times 3, which is 12, and then 12 times 2 is 24. I've got 2 negatives there, so it's going to be -24. Okay, so -3 times -2 becomes +6. 4 times 6 is 24, and then I've got that negative there. Okay, so just take your time with your negatives. I didn't really save much time by doing that 64, did I? Okay, so 64 minus 24 is 40 over -6. All right, so the square root of 40 you can simplify, so that becomes 2√10 over -6, and that's a plus and a minus. Okay, you can simplify now. I find it easier just to separate and then simplify. So we can have x equals, separate your plus and your minus. And then we've got x equals -8 minus 2√10 over -6. Now I'm going to take, this is where it can get tricky. I don't like having the negative here in the denominator. So let's divide everything through by the common factor of -2. So -8 divided by -2 is 4. -2 divided by -2 is -1. So it's going to be -√10. And -6 divided by -2 is 3. And then similar here. So we've got 4. Then we've got plus √10 over 3. Just going back to the start here, because I was just thinking of something as I was doing that. So question F, which is what we just did, if you wanted to, you could get rid of that negative here and turn that into 3x squared minus 8x plus 2. So you're changing the signs of everything. So you could go through and do that. You're not really changing the parabola at all. And the negative 8 wouldn't make any difference because negative 8 squared is still going to give you the positive 64. So as I was working through that, I thought it might be easier, just to prevent you from getting confused with the negatives, you can change the f to make that a positive. Whoops. This then would become a negative and this becomes a positive. So you can change the signs. It's kind of like saying, well, if I moved everything over to the right-hand side, I would be adding 3x squared, subtracting 8x, and adding 2. So you could either go through and do what I did, or if you're having trouble with your negatives, you can take the negative out as a common factor. All right, so I'm going to move now on to question 6 because this is going to be another long video. I put this one here because you can see it's not in your expanded form. You can't just go ahead and assume that your A is 3, your B is 6, and your C is 1. So you've got to get everything over to the same side. So the positive 6x comes over as negative 6x, and then we've got the negative 1. And then you can identify your A, B, and your C. So A is 3, B is negative 6, and C is negative 1. Now, I'm going to just move on to do a few. I'm not going to actually do the quadratic formula with that one because I want to show you a few others. Let's just do, I'm just trying to look at which ones you might need help with. So D, 2x minus 5 equals negative 1 over x. So let's first of all bring everything over to the left-hand side. So we've already got the 2x minus 5. And if we're bringing 1 over x over, I've got to add 1 over x. All right, at this point, it doesn't look like a quadratic. Let's just get rid of that 1 over x by multiplying both sides by x. Okay, so if I multiply both sides by x, obviously the right-hand side still stays 0 because 0 times x. But now I'm going to have 2x times x gives me 2x squared. Negative 5 times x is negative 5x. And then x times 1 over x is 1. Okay, and then you can identify your A, which is 2, your B, negative 5, and C is 1. All right, let's do another one. Okay, so I'm going to let you just go on and do the quadratic formula. Let's do G just because I can see it just peeking up the top there. Again, let's bring everything over to one side. Okay, so actually, no, let's not bring it over to one side. Let's just take our time. Okay, so let's get rid of that x on the denominator. Okay, so let's get rid of this x first. So multiply both sides by x, and that disappears. 5x times x is 5x squared. And then we've got 2x plus 2 on this. Oops. It's funny how I say one thing and then I write another thing. Okay, so 2x plus 2. And then let's bring that 2x over and that 2 over. And then we've got 0. So now it is in expanded form. So A equals 5, B equals negative 2, and C equals also negative 2. All right, girls, I'm going to leave it there. Please, if you need any help, do ask, but quadratic formula, as long as you can identify your A, B, and C, you can substitute them into the formula, you're good to go. All right, bye.